Let's take a look now at example 1 here on the Newton-Raphson method. Now we just simply have to find a root of the equation here for this given quadratic to 5 decimal places using this starting value here. Now the first thing we want to do here is define f of x, and f of x here will simply be the quadratic. So f of x will be this quadratic here. So x squared minus 8x plus 11. So that's our quadratic for f of x. And for f prime of x, that means we just need to differentiate f of x with respect to x. So that's hopefully nice and straightforward here. That's simply going to be 2x minus 8. Okay. So now what we want to do is define the formula that we're going to use. So that's the Newton-Raphson formula. And in this case, that's going to be xn plus 1. And that's equal to xn minus f of x. So that's our numerator. So that's x squared minus 8x plus 11. And that's all divided by f prime of x. So that's 2x minus 8. Okay. So what we want to do now is just take our starting value here of x0 equals 6, and we can find x1, x2, x3, and so on until we can find a root of the equation to 5 decimal places. So the first term we're going to find here will be x1. So therefore x1, well, that will be using the previous term here of 6. So in that case, that's going to be 6 minus 6 squared minus 8 lots of 6 plus 11 divided by 2 lots of 6 minus 8. So in that case, we get 6 minus 6 squared minus 8 lots of 6 plus 11, and that's all divided by 2 lots of 6 minus the 8. So here now we just need to put this into our calculator here and evaluate this, and what you should find here for x1 is this is equal to 6.25. Okay, so 6.25 gives us our value of x1. And now to find x2, we just use the previous term. So to find x2, we use x1 throughout. Okay. So in that case, x2 will be equal to 6 minus 6.25 squared minus 8 lots of 6.25 plus 11. And we divide that by 2 lots of 6.25 minus 8. So we put everything in there. 6.25 minus 6.25 squared minus 8 lots of 6.25 plus 11, and here we just divide this by 2 lots of 6.25 and we minus 8. Okay, and if we evaluate this here, what you'll find is quite a large answer in terms of decimal places. But what we get is 6.236, and then the 6 ones after this, so 1, 1, 1, 1, 1, 1 there. Okay. And the key here is to not start rounding at any point throughout this. We want to keep as much accuracy as possible so that it doesn't affect our final solution. So here, keep this to as many places as your calculator will provide. So here now, to find x3, we're going to use this value of x2. But what I'm going to do here is I'm just going to use a letter to represent this value here, and I will use that throughout. Okay. So let me just clear all this just so that makes a bit more sense. So because the value here for x2 is quite large, so we just note that here, x2 is equal to 6.236, 1, 1, 1, 1, 1, 1 there. Because this is quite a large value, what I'm going to do is I'm going to call this A. Okay, so I'm going to call that A. And what I'm going to do then for x3 is I'm just going to use A. However, I've already evaluated this on my calculator, and I advise you try this as well, okay, to make sure you get the same value. So here, what I'm going to do then is use our Newton-Raphson formula to find x3, and that's going to be A here, so it's going to be A minus A squared minus 8 lots of A plus 11. We divide this here by 2 lots of A, and we minus 8. Okay, and notice all I'm going to do then is actually use this value here in terms of instead of A, of course. So I'm just substituting that back in. So it's going to be 6.2361111 minus that value squared minus 8 lots of it plus 11 divided by 2 lots of it minus 8. Okay, but obviously because it's quite lengthy, it's just going to be a little bit easier to visualize that with this substitution. Now, if you do this correctly here, what you should find you get for x3 is, again, another lengthy answer in terms of decimal places. You get 236.067978 there. Okay, so notice this now, compared to x2, we haven't got a solution yet to 5 decimal places. So in that case, we need to repeat this, and hopefully what we'd find is on our next turn here for x4, we'll find we do get a root to 5 decimal places. So looking for x4 now, well, in that case, I'm going to use another value here instead of another letter instead of A. This time we'll call this B. Okay, so this is equal to B. And what I'm going to do then is just use B throughout here for x4. So that's B minus B squared minus 8 lots of B plus 11. And this is all divided by 2 lots of B minus 8. Okay. So here now, instead of obviously using B, we'd be using this value here. So you just need to substitute that in and evaluate that on your calculator. But what you should find here, what you get is 6.2336067977. And now if we compare our value for x4 to the value for x3, we notice now we have found a root to the equation here, this quadratic, to 5 decimal places. So, checking this now to 5 decimal places, so that's going to be 1, 2, 3, 4, 5. So in that case, taking a look at the value of the digit next here, that's the 7, that means we need to round up. So therefore, our root here is simply equal to 6.23607 there, to 5 decimal places. Okay, so that gives us the solution there to this example on the Newton-Raphson method.